Hello and welcome to this episode of Math with Martinez. We are in our Algebra 2, Unit 3 set of notes where we're looking at systems of linear equations and inequalities. And we have come to our last learning objective, and that is to formulate and solve systems of 3 linear equations using matrices. So let's jump to our notes on calculator tutorials, focusing specifically on matrices. You're going to need your TI-84 calculator while watching this video so that you can follow these steps and do them with me so that you become familiar with how exactly to organize things in your calculator using the matrices features. So all that a matrix really is it's just a collection of numbers that are organized into rows and columns. And so what we've got here are a couple of matrices. And what we're going to do is we're going to practice entering matrices into our calculators. So let's go ahead and split our view here with our calculator. All right. So what we're going to do is we're going to use the steps below to enter the matrix into our calculator. So first thing we're going to do is we're going to press our second button. It's that blue button. And then the button that's like X to the -1, it's actually, notice above that word, it says the word matrix. So there you are. You'll be in a screen that looks like this. What we're going to need to do is we're going to arrow over until we get to, like it says here, arrow over until you're in the edit category, like I am here. And then you're going to choose a matrix and press, go ahead and select it by pressing enter. We're going to press enter for matrix A because we're putting matrix A in right now. And then we need to choose the dimensions of our matrix. Well, this matrix right here has 2 rows and 1, 2, 3, 4 columns. So we call that a 2 by 4 matrix. 2 rows, 1 column. Remember that the dimension is always row by column. 2 rows, and then your columns are the things that are vertical. Rows are horizontal. All right, now we are on to step number 3, which is to go ahead and put the elements into your matrix. So just use your arrow key until you're actually in them, like in that area, and then start typing in those values. And every time you press enter, it'll just take you to the next spot. Make sure you use a negative, not a minus. And then there you go. We've now entered, oops, I'm so sorry. We've now entered all of that in. And if you wanted to go and now put in matrix B, then we would just start again at the top. We'd press second, and we would choose our matrix button. And we're going to go down and now edit matrix B. So to edit it, we need to go over twice. Arrow over to where it says edit. Oops, I'm sorry, I chose the wrong one. Let me do it again. Second matrix. I want to choose matrix B, arrow over, and then arrow over to where you're editing, and then select matrix B, not A. So you can see my matrix B is pink. Yours might be a different color, but I'm selecting that one now. It's blank, it's empty, nothing's there. All right, so matrix B is also a 2 by 4. So I'm going to go ahead and put 2. Enter, 4, enter, and now I've got the right size, and I can go ahead and enter in all those values into the little cells. There you go. And now your matrix is there. If you go to your home screen by pressing quit, you can actually go ahead and retrieve a matrix by going to matrix, then just selecting the one you want. And now your matrix A is here in your calculating area. So again, how did I do that? I just went to my matrix and I selected the one I'm looking for. And there it is. Now, what we're going to do is you can override existing matrices whenever you want. Like when you're done with all of this information, you can type over it. You can also press, you can reset your calculator to clear out all the data. But what we're going to do now is look at how we find the inverse matrix. So what we're going to do to begin with is we're going to input matrix C and D so that we have some more matrices to work with. So go to matrix, go to edit, and go down to matrix C. Let's get the right size. This is a 2 by 2 matrix. And we're going to put all that information in there. Okay, I've got matrix C. Now I'm going to go ahead and edit my matrix D. It is a 3 by 3. Okay, so I've got my matrices in there. And now we can go ahead and return to our main screen by pressing second quit. That's how you get back to this main screen. Clear it off, and it's all ready to go. Now we're going to go ahead and press the second and X inverse button to choose a matrix from our menu. The matrix that we're going to go ahead and choose is matrix C. And now it's here, ready to work with. We're going to press that inverse button, and what that is going to give us is our inverse matrix. And in just a moment, you'll see why having the inverse is going to be really important. Press enter, and there it is. The inverse of matrix C, if we write that out, the inverse of matrix C is the matrix whose elements are -9, -11, 4, and 5. And if we wanted to find the inverse of matrix D, we do this again. We go and select that matrix. We're not editing it, we're actually selecting it. And we press that little inverse key, and there you go. That would be our inverse matrix. There we go. Now, why would we want to find the inverse matrix? I am glad you asked. Well, it connects with what we're doing here with our solving of systems using technology. Remember that a system of linear equations can be written as actually a matrix equation. Check this out. If what we have here is a matrix that looks like this, and I'm going to highlight some values for us. We're going to begin here. When we've got our x's all in a line, like vertically, we can set it up like so. Okay, so what we've got here is a way of organizing all of the numbers in our system so that we are just working with matrices instead of with equations. So we write a matrix equation. So if you take your matrix and make sure that it's organized like you see here, where you have your terms that include x as the first column, the terms that include y are going to be there in that matrix as well. And then you've got it multiplying with this next matrix, equaling your constants. And each of these have a really unique name. Let me go ahead and close that calculator for a minute so I have my full keyboard here. Your matrix, this A matrix, is called the coefficient matrix. All right, it's called the coefficient matrix because it is actually all of your coefficients, your A, B, C, and D. Then you have your next matrix, which is called your variable matrix. And it's denoted with just an X. And then lastly, you have your final matrix, which is your constant matrix. And it is the constants, what your equation was equal to. And so if you think about that, then what this equation really, the way that we would really express this is to take our coefficient matrix, which is your A matrix, and you're multiplying that with your variable matrix. You see that right here? I'm taking my coefficient matrix, multiplying it with my variable matrix, and then that's going to be equaling the constants matrix, which I'm using B for that. So if I want to solve for X, you might be thinking here, oh, well, that's not hard at all. If I want to take and solve this, let me do that over here in the margin. Please do this with me. Oh yeah, Ms. Martinez, if that's what you want to do, then all you need to do is divide by X, and then you're like gonna be done, right? Well, I'm sorry, you guys. Actually, you cannot divide matrices. It's not a possible operation with matrices. So instead, what we do is we take our matrix and we do the inverse operation. Right now, it's multiplying, but we need to do the inverse operation of that multiplication, and that is to simply take your A inverse matrix. That's to take your A inverse matrix and multiply everything else by that. So then I'm going to take it like this, scoot this over. Whatever I do on one side, I have to do on the other side as well. So we would multiply by the A inverse matrix. And in doing so, when you multiply your A inverse and A, those are going to be opposite operations, and it will eliminate on that side. And so what we have is that our variable matrix, what we were looking for here, the values for X and Y that are going to be contained in that matrix are going to be the result of taking A inverse and multiplying that with your B matrix. So what are we going to need to do if we want to solve a system that has lots of variables and lots of coefficients? Well, we're going to write our system as a matrix equation. Get everything organized in beautiful columns and then set it up as a matrix equation. Step number 1. Then put it all in your calculator and find your A inverse matrix. And then you're going to take and multiply your A inverse by your constant matrix B. So let's go ahead and do that with this system right here. We're going to take and rewrite this as a matrix equation. So what I'm going to do is begin with my A matrix, and that's to take all my coefficients. My X's are in a column together, and my Y's are in a column together, so I'm ready to do this. The coefficient of that first term is actually a 1. And then in the same row, a 2, and a -1. That is going to be multiplying with our variable matrix, which is your X and Y. And it is equal to your constants, which is we're going to make it our B matrix, and that's 4 and 3. So we've written this now as a matrix equation. We've got A being multiplied with X and equals B. What we need to go ahead and do now is find our A inverse matrix. How are we going to do that? Well, I need to go put this matrix A in my calculator and my matrix B in my calculator so that they'll be ready to actually use. So let's go ahead and go and edit what our A matrix is. I'm going to go over to Edit, that A matrix, and I need to change its size. It's going to be a 2 by 2 matrix. And then I'm going to type over those values. I want it to be 1, 2, 2, -1. Great. Then let's go ahead and edit our B matrix. Our B matrix has, change its dimensions. It has 2 rows and only 1 column. And those values, there we go. Now let's go back to our home screen here. Need to find my A inverse matrix. So to do that, I'm going to go ahead and go to my matrix A and find its inverse. There it is. Go ahead and write that in here. 0.2, 0.4. Yours might be fractions, and if so, that's perfectly fine. You can just write those fractions. And now what we need to do is go ahead and multiply our matrices. So that's going to be, let me scoot this out for just a minute. If I want to find x, it's going to be that A inverse matrix, which is 0, 2, 0, 4, 0, 4, -0.2, multiplying with our B matrix. And that will give me my values for x and y, the solutions to the system. So let's do that. Let's grab our calculator and finish this off. So I'm going to take what I just had. I can go up and highlight that A inverse -1 and actually copy that down and multiply that now with my B matrix. Grab your B matrix. There it is. The solution to the system is 2, 1, which really means, what is our answer? The value, the x and y value, remember x and then y, 2, 1. That is the solution to this system. These two lines intersect at that point, which we found using matrices. Now, you could have used any one of our 3 previous methods, graphing or using elimination or substitution, for this particular example, because it's a very simple system with just 2 variables. Things get a little more complicated when you've got 3 or more variables. And this is when it's wonderful to be able to express it as a matrix. So I'm going to do that right now. I'm going to take this and write it as a matrix. That's a 1, a 3, a 2. +1, -1, 1, -2, 1, and 4. That is going to be multiplying with your variable matrix, which includes all 3 of variables, x, y, and z. Now we're working in a 3-dimensional plane, which is like the world we live in, 3 dimensions, not just up and down, left and right, but also including depth to it. And then we have -9, 13, 17. All right, we need to go find our A inverse matrix, figure out what that equals, because then we will take, and to find x, we will take and multiply our A inverse matrix with our B matrix. And that will give us our values for x and y and z. And we'll be able to give our final solution the x, comma, y, comma, and z values right here at the end. So let's go and do that. Let's go and put these values in to our graphing calculator. I'm going to edit over my A matrix. I'm going to edit it. I need to change its dimensions because my A matrix is now a 2 by 3. Make sure you've got everything entered in that matrix correctly. Oops. I'm sorry, it's a 3 by 3. And now we're going to edit our B matrix, which is going to have the dimensions of a 3 by 1. All right. Let's go to quit, clear all this out, and let's go get our A matrix. Find its inverse. Whew. Okay, so you may not be able to actually express the values there. They may be like you see there. But what we're going to go ahead and do is we're going to take our A matrix and then multiply it with our B matrix. All right. Now I actually know I should be getting nice integer values here, so let me go check real quick my matrix. I may have entered in something incorrectly. Oh yeah, look right there. That should have been a 1. Okay, and then a 2, 1, 4. Okay, great. There we go. So what I'm going to do here is I'm going to re-enter this, see what this gives me. Okay, so those are much nicer values. Let me go ahead and put those in here. So I'm going to go ahead and state my A inverse. It's 0.2, 0.4, negative 0.2, 0.24, negative 0.32, negative 0.04. And then all of that is going to get multiplied with that B matrix. So let me go ahead. I've got my A matrix, my A inverse matrix, and we're going to multiply that with our B matrix. And there we go. We have the solution to our system. It is the matrix 2, negative 3, and 4, which means our x value is 2, our y value is negative 3, and our z value is 4. So having matrices to help us solve these systems is so helpful, because doing it just algebraically is quite a doozy. So we are very grateful for this technology to allow us to find the solutions to these really complex systems. If you guys had any questions, please take a moment and share those now. And until next time, stay fired up.